Hello and welcome to another section in further mathematics. In this section we'll be looking at the topic geometric mean. Geometric mean. And when we talk about geometric mean, there are certain things we really need to discuss about it. But before that, let's take a quick review of our previous lesson. Okay, welcome back. Now, we did something when we were trying to calculate arithmetic mean. We said it's just about inserting numbers in between numbers. You know, mean, as the word implies, talks about average. So at this point, we want to talk about the geometric average of numbers. For example, if I should write a number 2 and I have 6 and I have x, I say look for the geometric mean of this number. You believe me that the geometric mean will be 4. Because I'm talking about that exists between 2 and 6. Because I'm actually talking about the number that serves at the midpoint between these two numbers. So the geometric mean between this and this will be 4. Now, but when it comes to geometric mean in a geometric progression, we usually employ the same formula that we are used to when it comes to geometric progression. So which is our Tn equals to ARn minus 1. You just use it in getting the same value that is needed. But this formula should be stocked. Always make reference to this formula each time you want to solve a question that involves a geometric progression. For example, let's call this example 6. We now say, if you're being told to insert 2 geometric mean between 12 and 3 to 4. Now all you need to do is remember between 12 and 3 to 4. So you have to insert 2 geometric mean. 2 more, that's to say you have to insert 2 more numbers. So what you need to do in essence here is you now replace the numbers as 2. Let the geometric means be x and y. Then we have 3 to 4. So with this, you bear with me that our a being our first term is 12, while the value of our, we have 1 2 3 4. So our T4 is 3 to 4. So let's use that of 3 to 4. So remember, T4 is equal to 3 to 4, which is the same thing as ARn minus 1. And you now have AR3 because this is T4. So we now have it as 12 times r raised to power 3 equals to 324. So r raised to power 3 is equals 324 divided by 12. So the value of r raised to power 3 is 27. So if r raised to power 3 is 27, so r becomes the cube root of 27, which is equals to 3. So the value of our r is 3. Now with this, we can now get the two numbers, like T2, which happens to be our x, will now be equal to AR. So we now do it as 3 times, that's our R is 3 and our A is 12, which is equal to 36. While our T3, which is equal to our Y, is AR2. So we now have it as 12 times 3 times 3, which is equal to 12 times 9, and 12 times 9 is 108. So with this, the value of x is 36 and the value of y is 108. So we've succeeded in inserting the two geometric means between x and y. But one of the things I want us to always understand is that when you talk about the sum of term of a sequence, when you talk about sum of term of a sequence of a geometric progression, there are things we usually consider. We check the value of the ratio. We have xn to being equal to a1 minus r raised to power n all over 1 minus r. That is if the value of your value of your r is less than 1, you make use of this. But if you have this r raised to power n minus 1 all over r minus 1, that is if the value of your r is greater than 1. Now these are the two formulas we use in calculating sum of terms of a geometric progression. If I say, for example, let's apply this and say, for example, under sum of terms, let's call it, this example 7. We can say the third term of a GP, the third term of a GP is 63 and fifth term is 567. Find the sum of the first six terms of the progression Now let's extract it. We have our V3 to be equal to 63, and the third term of is 63, and the fifth term, our T5, is 567. Now find the sum of this. So we have it now that that's T3 is equal to AR2, so AR2 is equal to 63, and T5 is equal to AR4, which is equal to 567. Now this is this. Now we have to solve. Let's call this our equation 1 and call this our equation 2. We have to solve simultaneously. Now let's have it this way, that AR4 is equal to 567 and AR2 is equal to 63. Let's divide by this. So A goes off. I'll divide by this. You have R square equals to 567 divided by 63. We have 9. So the value of our R is 3. So for that, the third term, find the sum of the first 6 terms. Since our R is 3, we employ this one that says Sn, which is our R is greater than 1. Sn equal to A in bracket R raised to power n minus 1 over R minus 1. So sum of first 6 term. So that's to say our n is 6. X6 is equals our first term here is the third term of a GP is 63, and the fifth term is this. Find the sum. Okay, we can also get the first term from here, stating that AR2 is equal to 63 and our R is 3. 3, 2 here is 9. A9 is equal to 63. So our A is equal to 63 over 9, which is equal to 7. So from here we have 7 in bracket 3 raised to power 6 minus 1 over 3 minus 1, which is equal to 7. 2 raised to power 6 is 729. 729 minus 1 over 2. So our S6 is equal to 2548. So with this, you can see that if the third term of a GP of a geometric progression is 63 and the fifth term is 567, then the sum of the first 6 term of the progression will give us 2,548. I will say a very big thank you for being part of this lesson. But in order to refresh your memory on what we've just discussed, please, it will be advisable you take the test that will be appearing shortly on your screen. Do well to use the lesson notes on the platform for a better information on the topic we've just finished discussing. Thank you.